Okay, the last data set that we need to talk about is what's called a line plot, and then we'll talk a little bit about tables as well, but you should be a little bit more familiar with tables. So with a line plot, we have a mark like an X or a dot for each number that is in a data set. The line plot below was created from this set of numbers, 0, 0, 1, 1, 1, 1, all these numbers here. So for each of these numbers, we have an X on this line plot. So as you can see, there's 2 zeros, therefore we have 2 X's at 0. Right, there's 1, 2, 3, 4, 5 ones, so there's 5 X's at 1. Right, and that's what a line plot looks like. So if we're looking at this line plot, it's asking how many people ate pizza 2 times last month. Well, we find 2, and we just need to count how many X's are at 2. Let's see, there's 1, 2, 3, 4, 5, 6, 7 X's at 2. And so there are 7 people ate pizza 2 times last month. Because there's 7 X's at the number 2. So now we're going to be comparing and contrasting some line plots by looking at means and standard deviations. These are going to be the 2 key vocab terms for this section, is finding the mean and the standard deviation. The mean, or the average of a number, is found by adding all the numbers together. So we're going to add all the numbers. And then we're going to divide by the number of pieces in the data set. So essentially, we're going to add all the numbers together and then divide by however many numbers there are. So for this one, we have 2 zeros. So here's 1, 2 zeros. We have 3 ones. So 1, 2, 3 ones. We have 5 twos. So 1, 2, 3, 4, 5 twos, etc. We're adding all the numbers that we have together. So I would take 0 plus 0 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4. Add all the numbers together. And what we get is 30 when you add all those numbers together. Then we need to divide by how many numbers we have. So looking at this data set, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. So I take the 30 that I get by adding them all together, I divide by 15, because that's how many numbers I have, and that gives me 2 would be the mean. You find the mean by adding all the numbers together and then dividing by the number of numbers that you have. Okay, the mode, another kind of key vocab term, is the number that appears the most. So if we look at all of our numbers that we have 0, 1, 2, 3, and 4. I want the number that has the most, and it looks like that would be 2. 2 is the number that I have the most of. So 2 would be the most because I have 5 of them, and that's the most that I have. Let's see. So 2 is the number that we have the most of, and so that is the mode. To find the median again is the middle number. So if you look at all the numbers that we have, the middle number, if we have 15, let's see, I'd have 1, 2, 3, 4, 5, 6, 7 over here. 1, 2, 3, 4, 5, 6, 7 over here. So yes, this is the middle number, which is 2. So the median would be 2. So those are some different things that we can find from a dot plot or a line plot. So now we need to talk about symmetric distribution. When you have, it's very similar to the histograms, when you have distribution where it's kind of the same on both sides, so the data is even on both sides of the middle number. If we look at 2, the rest of this kind of looks the same on both sides. It kind of goes up and then down. We would say this is symmetric. Sometimes you will also call this normal. So it's symmetric, or you could say it's normal. Okay. If a distribution is perfectly symmetrical, which means it's exactly the same on both sides, then you can determine the median, the median, the mean, and the mode based off of the middle number that's the highest. So if you look at this 2, it's the middle and it's also the highest, so that's going to be our mean, median, and our mode, because these other numbers are exactly the same on both sides. Okay, then we're going to talk about standard deviation. Standard deviation measures how far spread out a data set is around its mean or average. So standard deviation is going to measure how spread out your data is. The key thing here is that if you have a wide spread, then you have a high standard deviation. If you have a wide spread, you have a high standard deviation. So if you look at Farmer Dell's plot here, you can see we have kind of a wide spread because we have a lot of different numbers that can be used. These are not all bunched together in the middle, they're spread apart. So this standard deviation would be higher. It's kind of a high standard deviation because it's a wide spread. However, if you have a narrow spread, that means you're going to have a lower standard deviation. And so what that means is that if you look at Farmer Brown's distribution, all of these numbers are kind of bunched together in the middle. So this is going to be a lower standard deviation because they're all kind of bunched together. There's very few different numbers that these pumpkins represent. They're all kind of clumped together in the middle. So if we look at Farmer Dell and Farmer Brown's, they ask which one would have a higher standard deviation. The higher standard deviation would be Farmer Dell's because he has a wider spread. So we'd say Farmer Dell because he has a wider spread. Okay. Then I ask you to find the mean weight of the pumpkin in Farmer Brown's garden. So we could do that by adding all of these numbers together and then dividing by however many numbers we have. But it gives you a hint. The middle of the graph is going to tell you the mean because this is perfectly symmetrical. We have 4 in the middle and then 3 on each side. So it's perfectly symmetrical, which means this middle number would be our mean, and that is going to be 180. Okay. Finally, when looking at a table, we're going to be wanting to find the standard deviation of a table as well. And one thing we can use is what's called the range rule of thumb. It's not always precise, but it is frequently an easy way to compare the sets of data to determine which has a higher standard deviation. So the range rule of thumb is that you need to find the range of the data by subtracting the smallest number from the largest number, and do this for both sets. The data set with the largest range probably has the highest standard deviation. So one way you can find which table would have the higher standard deviation is to find the range of both, and then whichever has the highest range probably has the highest standard deviation. So looking at these two tables down here, first thing we want to do is find the range of each set, which again is the highest minus the lowest. So for the range for this speed on Cactus Avenue, the lowest number that I see is 14, and the highest number that I see is 40. So to find the range of this Cactus Avenue, I would take 40 minus 14, and that is 26 would be the range. Okay, then I need to find the speeds on the desert way. For this one, it looks like the highest number that I see is 38, and the lowest number that I see is 28. So to find the range, I would take 38 minus 28, and that gives me 10, which is the range for the desert way. So it says, which set is likely to have a higher standard deviation? Well, the Cactus Avenue is likely to have the highest standard deviation because it has a higher range. It likely has a higher standard deviation because it has a higher range. Then ask which number in the data set caused the range or the standard deviation to be so large and why. So for that, I'm looking for a number that is either really big or really small compared to the other numbers. So if I'm looking at the speeds on Cactus Avenue, I see 32, 33, 36, 35, 33, 37, 30, 40, and 14. Those are my numbers. What I can tell is that most of these numbers are actually pretty close to each other. Like all these numbers are kind of close, 40 is kind of close, but 14 is a number that's way smaller than all the other numbers. So 14 is the number that kind of causes the standard deviation to be bigger because it's so different than all the other numbers. So we're looking for a number that's very different from the other numbers that will give you a reason for the standard deviation to be different. Okay, so that is the end of our notes for this packet. I'm sure that there were several things that were confusing. Again, these last couple pages are yours for practice to do on your own. But again, I'm more than happy to answer any questions that you might have. I'm sure you will have some questions as you go through these. So please make sure you are asking those. That way you are ready for when we take the test at the end of this unit.